Good evening, sir.
Evening. Yes, let me start. Briefly introduce yourself. Then we will discuss.
So my name is Avantika. I belong to Hisar. I have completed my schooling from Holy Angel School, Hisar, and I have done BSc-MSc dual degree course in chemistry honors from Guru Jambeshwar University of Science and Technology, Hisar, which is in Haryana.
Yes, good. Last day we have discussed chemical kinetics. Yes, this topic.
Yes, sir.
Last one topic. Second order.
Order. Yes, sir. Order.
Third order. Order
Second
is
order.
completed.
Yes, sir. So today was coordination last part. Huh?
Have you prepared?
Yes, sir.
Yes. Yes, the stability of complex and reaction mechanism. Yes, no.
Yes.
What is reaction mechanism in inorganic chemistry?
Sir, the reaction mechanism of any reaction involves the stepwise many elementary reactions which results in the final overall product, and that complete stepwise elementary reactions to complete the overall reaction is called as reaction mechanism.
What the difference between inorganic reaction mechanism and organic reaction mechanism? What's the difference?
So in case of organic reaction mechanism, the reaction is the reaction mostly occurs between the substrate and reactant, depending on the reactant which we are taking. But in inorganic chemistry, the reaction mechanism mostly followed by substituting the like in coordination with by substituting the one ligand by another.
Substitution reactions. Yes, no.
Yes.
What is substitution reactions?
Sir, substitution reaction in coordination chemistry, uh, in the coordination complex, one ligand is replaced by another ligand, then it is called a substitution reaction. It in coordination chemistry, it is of three types. That it is this in octahedral complexes. It follows dissociative mechanism, associative mechanism, and interchange mechanism.
Yes, reaction mechanism is so many types in inorganic chemistry. What's the difference between associate, dissociate reaction?
Sir, in case of dissociative mechanism, the ligand, like if in octahedral complexes, the coordination number is 6, and let us we take the ligand ML5X, then the ligand L we take as inert and X as labile, and we uh, take the ligand which have to be substituted as Y, then that will replace the X. But in the difference is that in dissociative mechanism, the firstly dissociation occurs and the coordination number changes from 6 to 5, and then the replacement of ligand is uh, done, and again the coordination number becomes 6. But in associative mechanism, uh, the ligand to be replaced uh, is the ligand to be replaced is joined to the metal, and at the same time the ligand which is replaced is breaking. So in associative mechanism, the coordination number increased, and then after leaving the ligand, it again retains its coordination number 6. And in dissociative mechanism, the intermediate is mostly of trigonal bipyramidal, and in case of associative mechanism, it is of PVP.
What's the difference between labile and inert complex? And which one more stable and why?
Sir, labile complexes are those complexes in which the ligand is substituted easily, and inert complexes are those complexes which are inert to react. So they don't replace the ligand easily, or we can say in labile complexes substitution reaction occur easily, but in inert complexes the substitution reaction can't occur easily. And the labile complexes, the substitution reaction is fast, so it is the complex is less stable. And in case of inert complexes, the substitution reaction is not occurring easily, so that are more stable.
Reaction mechanism, two terms used in a reactions. Thermodynamically stability and kinetically stability. What's the difference of these one? What the main purpose of these type of word in coordination and reaction mechanism?
Sir, thermodynamic stability for a complex, we can define it as the complex can be thermodynamically stable if it exists under equilibrium conditions, or we can define it in other words like if the metal have a tendency to combine with ligand and form complex, the tendency of metal to form complex is known as thermodynamic stability. And to and it the constant for mm, uh, forming complex here is known as formation constant, and in uh, kinetic stability the rate of reaction is measured, whereas in thermodynamic stability the stability to form complex is considered, and in kinetic stability the uh, rate at which the complex will react or is called as kinetics. And there are uh, constants, the formation constants, like if we have to form a tetrahedral or octahedral complex, then if we combine the metal with first ligand, we can denote by the K1 formation constant, and it will be ml. Then similarly in succeeding like these steps, we will have the uh, different types of formation constants as K1, K2, K3, and which can be at last which can be written as beta is equal to K1 into K2 into K3 into K4.
Explain on board which reaction is so thermodynamically stability and which reaction is so kinetically stability with example. Yes, good.
Sir, in case of thermodynamic stability, the if we take the metal and we mine it with ligand, then the formation constant L. And similarly, if we do here ml and minus 1 plus L, then it becomes final as ml, and then here the stability constant can be given into K2 into K3. There are the reactions in mostly reactions uh, K1 is greater than K2 and K2 is greater than K3. For example, um, for example, For example, we have cobalt H2O 6 3 plus, and here the ligand is NH3, then it will be Cu H2O 5 NH3, and one water molecule is released, and in another Cu H2O 5 NH3 plus ammonia, we will again have Cu H2O 4 NH3 twice plus water. In similar way, we will replace the water molecules by this ammonia ligand, and this is the example of the reaction in which the formation constant K1 is greater than K2, greater than K3, and so on. Because in this reaction, the product are the number of products forming are same, and in every reaction one water molecule is released, so the entropy is not increasing. So there are some reactions in which Kn is greater than Kn minus 1. One example of the reaction in which Kn is greater than Kn minus 1 is like if we like suppose if we replace the similar ligand that we have taken previously by ethylene diamine, then here in this reaction CO H2O 4, because En is a bidentate ligand, so it will replace two water molecules, and here two water molecules will be released, and if we take if we take if we take En4, here if we take diene, then it is a it will replace
Yes. Next, move up. What is the factor affecting stability of complex? Yes. Good. Basic. Which factor affecting in chemical reactions? And which factor is affecting in stability of any complex?
Sir, the factors which affect the stability of a complex in coordination chemistry, we First factor is the metal ion. If the charge on metal ion is more than the ligand which are uh, sigma donors ligand will be more stable with that, and if the metal is in low oxidation state, then the pi acceptor ligands will be more stable with them. And the another factor is a ligand. If the metal is like if the if we have taken platinum plus 2, then it is a soft metal. So here HSAB principle will work, that hard interaction is more stable and soft interactions are more stable. Then like if we have taken platinum plus 2 as metal, and if we compare the stability with the ligands like F minus, Cl minus, Br minus, and I minus, then I minus is softer than Cl minus, and Cl minus is softer than Br minus. So the platinum plus 2 will make a more stable complex with the ligand I minus as compared to the Cl minus and then Br minus. And the third factor is a chelate effect. If the ligand is if there is a chelating ligand that is forming a chelate ring with the metal, then that complex will be more stable. And if the chelate ring if the chelate ring has more members like 5, 6, or 7, then in that case the the 5-member chelate ring will be more stable than 6 and then 7, because in if there is a short chelate ring, then there occurs a strain, so that complex will be less stable. And if there is a large large chelate ring, then the donating atoms will be in less vicinity to the metal, so that will also less stable. So the mostly the chelating, the 3 4 5 and 6 member chelate rings are more stable with the metal ion. And the fourth factor is the steric factor. If the uh, if the bulky group is attached to the ligand, or there is bulky ligand, then that complex with the metal will be less stable. For example, if we have taken the ligand ethylene diamine and another ligand as tetramethyl and tetramethylene and dimethyl, then this is the bulky ligand, and this will be less stable as compared to the uh, ethylene diamine ligand with the metal. And
Yes, resonant effect.
yes, a resonance effect also, like if we have acetyl acetonate as a ligand, then here resonance will occur, and so it will form a stable complex with the metal ion.
Yes, macrocyclic effect.
Yes, in case of macrocyclic effect, if we have taken the macrocyclic ligand, for example chlorophyll, hemoglobin, then these are macrocyclic ligands are cyclic polydentate chelating ligands, and if they are of appropriate size, then they form more stable complex with the metal. The macrocyclic ligands form more stable complex as compared to the chelating ligands, which are not cyclic.
Yes, good. What is Irwin-Williams series? What the purpose of this series in coordination chemistry?
Sir, in Irving William series, the uh, the metal it is the metal it determines the stability of the metal, which metal ion is more stable than, like it is inversely proportional to the radius. For example, if the series of Irving Williams series is barium 2 plus strontium 2 plus, and if we go in this series, but in last the copper 2 plus has more than the Zn 2 plus, because the the radii of copper 2 plus is less as compared to the Zn 2 plus.
Yes. What is the measurement of this series? What the criteria of this series in periodic table and any other concept?
Like we have it is depending on the charge density, that is charge upon radius. So the in a periodic table there are factors which there are in periodic table we will, like in if we go along the period, then the size will decrease. So we can guess that the stability, and if their oxidation state is same, and
Yes. यस, मेरा कहने का मतलब ये है, इसको किस मेजरमेंट के अकॉर्डिंग रखा गया है, कैसे बनाया गया है इसको, मेजरमेंट क्या है इसका, जिस ये सीरीज बनाई गई है तो किस तरह से बनाई गई है?
कॉम्प्लेक्स स्टेबिलिटी के लिए
यस, कॉम्प्लेक्स स्टेबिलिटी के अकॉर्डिंग बताया गया, सही है पॉइंट आपका। लेकिन इसमें वो बताया जाएगा ना, ऑक्सीडेशन स्टेट, स्टेबिलिटी ऑफ द कॉम्प्लेक्स, इंक्रीज विद डिक्रीजिंग ऑफ द साइज ऑफ मेटल।
यस
इसमें कोई भी मेटल्स है जैसे M+2 आयंस है, उसका क्या हो रहा है, उसके जो ट्रेंड है वो स्टेबिलिटी ऑफ कॉम्प्लेक्स, उसके अकॉर्डिंगली तो डिफाइन किया गया है ना, एडजस्ट किया गया है। तो ये है मैम, इसका कोई रिलेशन है CFSE से, एनी रिलेशन बिटवीन इट विल बी सीरीज एंड CFSE?
Yes, sir. When we in we when we draw the graph of plus two three plus two 3D series metal ions, then we तो उसमें ग्राफ बनाते थे इसकी उस साइड की
Yes, variation formation of constant. वो ग्राफ किसको रिप्रेजेंट करता है? द पर्पज ऑफ दिस ग्राफ इन इरविन बिरविन सीरीज. क्यों बनाया गया, क्या रीजन है इसका? तो नहीं देखना आप थोड़ा.
सीएफएससी के अकॉर्डिंग भी देख सकते हैं कि जिसकी सीएफएससी ज्यादा रहे विद सेम लिगेंड्स.
इसका जॉन टीडी से जेटीडी से भी रिलेशन है, जॉन टेलर डिस्टोर्शन से भी. ये बेसिक
यस, लास्ट में कॉपर 2 पॉजिटिव तो ज्यादा स्टेबल इसीलिए हो जाता है क्योंकि उसमें जेटीडी.
जेटीडी है, ये बेसिक भी ज्यादा आएगी.
यस.
तो इंटर रिलेशंस हैं, तो वो सारे कॉन्सेप्ट होने चाहिए. इंटर रिलेशन आप कर लेना जो भी है. ठीक है, क्रॉस क्वेश्चन हो सकते हैं. जैसे इतना डीपली जाएंगे नहीं, स्टीफन ट्रेनिंग में इतना डीपली क्वेश्चन नहीं पूछेंगे, तो साइंटिफिक ऑफिसर में होता है ज्यादा. अभी हमने डिस्कस किया था बिफोर एसोसिएटेड एसेंबल मैकेनिज्म, डिसोसिएटिव एसेंबल मैकेनिज्म. ये क्या डिफरेंस है इनमें?
सर डिसोसिएटिव मैकेनिज्म में पहले डिसोसिएशन होता है और वो कॉम्प्लेक्स कोऑर्डिनेशन नंबर डिक्रीज होता है और उसके बाद वापस रिटेन होता है. लेकिन एसोसिएटिव मैकेनिज्म में ब्रेक पहले एसोसिएट होता है जो द लिगेंड व्हिच हैज टू बी रिप्लेस्ड is attached to the metal. The coordination number increase कर जाएगा, उसके बाद वापस से डिक्रीज करेगा.
यस. ट्रांसपेक्ट क्या, व्हाट इज ट्रांसपेक्ट?
So the trans effect can be defined as the ligand the the ligand which is trans to it will we- weaken that bond by decreasing the stability of that bond, and that will that the trans ligand will be replaced, and this is done by decreasing the activation energy.
What the difference between cis and trans plating? What is the uses of these one?
Sir, cis plating is used for cancer detection. And the cis and trans plating can be differentiated by Kornakov test.
Yes.
So, cisplatin has medical applications.
Redox is what is redox reactions? One electron transfer, two electron transfers. है ना? What the difference between outer sphere mechanism in electron sphere? Inner
So
sphere.
electron transfer redox reactions are those reactions in which reduction and oxidation occurs. Reduction is loss of electron and oxidation is gain of electron. So redox reaction can be defined as the reactions in which loss and gain of electrons occur. And in an electron transfer reaction, the electron is transferred from one complex to the other. There are, in case of a outer sphere mechanism, the outer sphere mechanism is also known as a tunneling mechanism because in this no bridging ligand is required, and outer sphere mechanism occurs when electron transfer occurs from T2G to T2G orbitals, and inner sphere mechanism, in case of inner sphere mechanism, bridging ligand is required, and inner sphere mechanism occurs in those where transfer of electron occurs from EG orbital to EG orbital. We can say sigma star to sigma star, and in outer sphere mechanism, the electron transfer occurs from pi star to pi star.
Yes. Yes, one electron, two electron transfer. What is the difference?
So one electron transfer into electron transfer.
Yes.
So in case of one electron transfer, in case of self exchange reaction, the metal ion is same in two complexes, and one is in more oxidation state and another is in less oxidation state. The metal which is in less oxidation state will donate its one electron to the metal in a higher oxidation state. So here electron transfer is occurring between the same metal of different oxidation state, and this is known as self-exchange reaction.